Hey Math 8 guys, this is Mr. Waddell. We're doing one more video on algebra tiles. So previously we looked at area and perimeter. Today we're going to look at combining like terms and the negative tiles. So you've probably noticed that your tiles have two different colors. One side's blue, one side's red, one side's green, one side's red, and one side's beige and red. So no matter what tile you're using, red always means negative. So this is the negative side of the x squared tile, the negative side of the 1 tile, and the negative side of the x tile. And we've also introduced this idea of something called an expression mat, which for us is really just one big place to stick our algebra tiles right now. It becomes a little more complicated later on. So for now, it's just a place to stick the algebra tiles. Since I have a big pile of algebra tiles here, are not part of the equation. Here is my equation. And a big concept for us right now would be 0. So this is a 0. X minus x cancels out. 1 and negative 1 cancel out. X squared and negative x squared cancel out. So all of this here on this map, even though there's all these tiles, in reality that's 0. Because this cancels with this, make a 0 pair, and they can be removed. This cancels with this, make a 0 pair, they get removed. This cancels with this, 0 pair, removed. And you're left with nothing, 0. Okay? So it's a cool way to start simplifying expressions by looking for these 0 pairs. So I'm just going to make an expression here. I'm not even sure what I'm going to make yet. I'm just grabbing tiles at random from my pile. I highly encourage you to do the same. Here is a small collection of algebra tiles. Nice little collection here. All you do for this is you go through and you find the things that make 0 pairs. So my biggest, most obvious one is these guys, my x squareds. Positive x squared, negative x squared. Make a 0 pair, gone. Negative x, positive x, 0 pair, gone. Negative 1 and a positive 1, 0 pair, gone. Negative 1, positive 1, 0 pair, gone. Negative 1, positive 1. Make a 0 pair, gone. And the actual answer here is x plus 1. So we're able to take something vastly complex, full of all these different variables, different constants, and you're able to take that and simplify it down to just an x and a 1. Let's try another problem. And really the best way to do this is to just play. Just mess around with these. Solve problems, try to simplify them. In reality, we can take very, very complicated structures and make them trivial with algebra tiles. And that's why they're cool. That's why we spend so much time learning these, is it takes stuff that's kind of hard to do and turns it into just a game of finding reds and greens, finding reds and beiges. That's all this becomes. So we got a green, we got a red, we form a 0 pair, they're gone. We got a green, we got a red, we form a 0 pair, gone. Red, beige, 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 0 pair, gone. Left with negative 2x plus 2. So we can take very, very complicated structures and make them into almost a game. And anything that turns complicated math into a fun game that you actually don't mind playing on a Saturday morning is good by my book. So hopefully this makes a little more sense as to what it is that you're doing, and give this a shot. Try your own, try copying what I was doing. Watch the video again if you need it. I'm here to talk with you in the mornings and the after school times. So if you're having any trouble with this at all, come see me and get this down now, because we're going to spend probably about 3 more weeks talking about algebra tiles. There's probably going to be more videos, assuming these are helpful for you guys. So hopefully this is getting you on the right track. If there's any confusion at all, you'll be able to hopefully get that cleaned up this weekend so we can move forward and do some more good work with these guys. So I hope everyone got something out of this, and I'm going to go upload these to YouTube. So have a good weekend, and I will see you